Okay, let's unpack this. I want to start this deep dive with a bit of a thought experiment. It comes right from the source material we're looking at, and honestly, it's a bit of a brain breaker.
Oh, I like those.
So I want you to imagine a room, just a neutral space. And in one chair, we have a sage astronomer from antiquity.
Hmm.
Let's say a high priest of the Maya civilization. Someone who has spent every single night of their life just mapping the stars.
Okay, so a true master observer from the past, naked eye expert.
Exactly. And in the other chair, across from him, we have a top-tier modern astronomer, someone from, I don't know, NASA, or a lead researcher at a big observatory. You know, someone with all the gear, supercomputers, satellite data, the works.
Two heavyweights. I mean, two people who have dedicated their entire lives to the exact same subject.
You would think so. They're both looking at the same sky. But here's the hook, and this is the whole premise of the text we have today. They wouldn't just struggle with the language. The sources argue they couldn't have a comprehensible conversation. At all.
Wait, even with a universal translator?
Even with one. They would be completely talking past each other.
Because of the math?
Where
Or is it a different kind of science?
It's deeper. The argument is that they're living in two totally different conceptual universes. The texts call this disconnect a scientific void, or in the original, a vazio scientifico. It's not the words, it's what they're looking for when they look up.
Wow. Okay, that's a really bold claim to start with. Because you just assume, well, math is math.
Right.
An orbit is an orbit, gravity is gravity, whether you're carving it on a stone tablet or running it on a supercomputer.
That's what I thought, too, going into this research. But our mission for this deep dive is to unpack why that assumption might be, well, wrong. We're looking at a few documents here, a technical synthesis, a blog analysis on this exact incommunicability, and a corrected text from a 20-year study on calendars. And they're all basically saying that while modern science has mastered the when, we've completely lost the how.
And that distinction, the when versus the how, that's the absolute core of it. To get this scientific void, you have to look at what each side values. The sources, they concede very clearly that modern astronomy is perfect and rigorous when it comes to time.
Meaning our ability to predict things.
Precisely. You ask a modern astronomer when the next solar eclipse will be, they'll give you the date, the hour, the minute, the second. 1,000 years from now, we can land a probe on a tiny asteroid moving at incredible speeds. Our timetable is flawless. We have conquered time.
So we have the schedule down cold. We know exactly when the train gets to the station.
We have the schedule. But the sources argue that by focusing so much on the schedule, the time we've sacrificed to the space, the ancestral view, especially the Maya perspective they reference, wasn't just checking a watch. They were obsessed with the physical journey, the actual step-by-step geometry of how a planet moves through the sky.
It's the difference between knowing the train arrives at 8.05 and knowing every single curve and incline on the track it took to get there.
That's a perfect analogy. We're just looking at the arrival board. The ancients were walking the line, inspecting the rails. And this leads to a really sharp critique in the texts about how we learn astronomy. They call it the basic trap.
Oh, I definitely fell for that one. It's burned into us. Think back to school, right?
Yeah.
You get that little styrofoam model, the sun in the middle, the earth, the moon.
And that's it. Earth goes around the sun, moon goes around the earth. Done.
Resolved. That's the word they use, right?
Yes. Resolved.
Yeah.
It's presented as basic, settled knowledge. Let's move on. We treat it like the alphabet. You learn it once, and you never think about the actual shape of the letter A again.
And the sources say that's exactly where the disintegration starts. By calling the Earth-Moon-Sun dynamic basic or trivial, we stop looking at it. But for the ancients, this wasn't basic at all. It was primordial. It was everything. They didn't see a simple loop. They saw a complex laying geometry.
So because we think we know it, we've actually stopped seeing it.
We've put it in a mental box that says stuff I know.
Yeah.
We just taped it shut.
Exactly. We've abbreviated it. The text uses that word. We've settled for the short version of the solar system. And when you abbreviate something that complex, you lose all the nuance. You lose the connectivity, and you really, really lose the sense of motion.
Okay, let's talk about that abbreviated motion.
Yeah.
Because this was the part of the reading that, it literally made me put the paper down and just stare at the wall for a minute. It challenges the shape of the orbit itself.
The shape of the journey, yes.
If I ask anyone on the street, what shape is the Earth's orbit? 99 out of 100 people will say an ellipse, a squashed circle.
And, in our standard model, they're right. We teach the solar system as a flat plane, the ecliptic plane, like a dinner plate. The sun's in the middle, and the planets just go around in these elliptical paths year after year.
But the sources say that's wrong, or just not the full picture.
Incomplete is how they put it. The texts argue the ancestral view describes the movement not as a closed loop, but as a spiral.
A spiral in space-time. Okay, let's break that down because my brain immediately wants to fight that. Why a spiral?
Well, think about the physics we tend to forget. We visualize the solar system like the sun is just stuck in one spot, but it's not. The sun is a star, and it's rocketing through our galaxy at, what is it, like 800,000 kilometers an hour. It's dragging this entire solar system with it.
So the center of our dinner plate is also moving. It's flying forward.
Right, so if the Earth is circling the sun, but the sun is moving forward, the Earth can't be tracing a closed circle, it's tracing a coil, a corkscrew stretching out through space.
That completely changes the mental image. An ellipse is static, it's repetitive. A spiral is dynamic, it's going somewhere.
And that's the space they say we ignore. I mean, obviously, modern science knows the sun moves. But in our description of the year, in our calendars and our models, we flatten it out. We focus on the periodicity, the time it takes. We ignore the actual geometry of the path.
We ignore the fact that we never ever return to the same physical spot in the universe.
Never. When you have a birthday, you are millions of miles away from where you were last year, further along that cosmic spiral. The Mayas, according to this study, were mapping that specific, non-repeating, step-by-step journey.
So we've traded the territory for the map. We have a great map of when things happen, but we've forgotten what the landscape actually looks like.
And that trade-off gets technical. This is that idea of disintegration from the texts. Modern science teaches rotation, the Earth spinning for a day, in translation, the Earth orbiting for a year, as two separate things.
Right. Different chapters in the textbook, I remember that.
But you can't separate them. In the ancestral view, it's one joint, continuous movement. The spinning and the spiraling are part of the same fluid mechanic. By breaking them apart, we disintegrate the reality of the motion.
This reminds me of the section on the wobble. The text gets into something called nutation. Now, for anyone listening who hasn't brushed up on their astrophysics lately, what is that?
Sure. Picture a spinning top. As it slows down, the handle starts to wobble in a little circle. That wobble is nutation. The Earth does the same thing as it spins. Its axis isn't perfectly steady. It nods and sways slightly over an 18.6-year cycle.
Okay, the Earth is a wobbly top. Why is that a point of conflict here?
This is where the sources get a little controversial. They claim modern explanations for this are inconclusive or unclear.
Really? I always thought we had that figured out. Isn't it just the moon's gravity pulling on the Earth's equator?
That is the standard model, yes. We say the moon acts as a torque on the Earth. But the sources argue that ancestral astronomy didn't see it that way. They claim that because we've disintegrated the movement, separating the spin from the spiral, we're forced to find external causes, like the moon, to explain the wobble.
Hold on, explain that. Are you saying that because our model is in pieces, we have to invent or overemphasize forces to make the math fit?
That's the implication. The text says our model of the Earth-Moon dynamic is incomplete. It implies that if you saw the movement as one continuous spiral, the wobble might just be an intrinsic part of that geometry, not just the moon tugging on us.
So we might be misinterpreting the whole Earth-Moon dance.
It suggests our model isn't complete, that even with all our tech, we fail to describe the Earth-Moon cycles in an integrated, complete, and continuous way. We have data points, but not the continuous step-by-step geometric description that the ancients apparently had.
It feels like a bold accusation. That we have the bones of the solar system, but not the connective tissue that holds it all together.
And nowhere is that more apparent than with eclipses. This, for me, was the master key in the whole thing.
The trauma de terra.
Yes, the Earth web, or the Earth plot.
So before we get to the web, let's talk about the eclipse itself. Today, an eclipse is a spectacle. It's an event, you get the glasses, you go to the park, you watch for a few minutes, and then you go home. It's cool, but it's isolated.
An anomaly, a break in the routine.
But for the Mayas,
it was the central pillar of their knowledge. It wasn't an event, it was the structure. Eclipses were the tool they used to map the order, proportion, and harmony of the entire system.
how does an eclipse map a system? I just think of it as the moon getting in the way of the sun.
Well, think about that spiral again. If the Earth is moving through a spiral and the moon is weaving its own path around it, an eclipse isn't just a shadow. It's an alignment point. It's a coordinate where all the gears of the system click into place. By tracking the exact interval and geometry of those clicks, not just the time, but the angle and the space, they could reverse engineer the shape of the spiral.
Ah, so they were using the shadow to see the invisible structure, like throwing paint on an invisible man to see his outline.
Exactly, that's what the source means by trama da terra. They were mapping the weave of the orbit. The modern astronomer uses an eclipse to check the clock. The ancient astronomer used it to check the path.
And that's why the sources say their method was superior in describing space. They were watching the process, not just skipping to the result.
And doing it with just their eyes through generations of observation. The study suggests they had a step-by-step description of these coordinates that we just don't bother with. We assume the ellipse and we calculate the intercepts. They didn't assume, they watched.
I want to get to the so what of all this, because I can hear someone listening and saying, okay, that's cool, the Earth moves in a spiral, but my GPS works. The seasons show up on time. Why does it matter if I think of it as an ellipse or a spiral?
That is the ultimate huge cultural void. It's not just about the math, it's about meaning.
Meaning in like a spiritual sense.
In a really profound sense, the text explicitly links this basic view of astronomy to a sort of a disenchantment with the world. By treating the orbit as a simple, repetitive loop, something trivial, we've stripped it of its grandeur. We've turned the cosmos into a clock on the wall. It's mechanical and useful, but it's dead.
It doesn't tell a story anymore. It just tells time.
That's a beautiful way to put it. For the ancients, observing this order, proportion, and harmony through the spiral wasn't just data, it was validation. The sources say this astronomical order provided a rational explanation for the association between the sky and the sacred.
Now, that's a flip. Usually we're told that God and the sky is superstition, and science came along and proved it's all just rocks and gas.
Right. But these sources are arguing the opposite. They're saying the science of the ancients, their rigorous observation of that spiral harmony, was what proved the existence of the sacred to them. It wasn't blind faith. It was based on observing the trama da terra. They saw a system so perfectly integrated, it rationally justified a belief in a higher order.
So for them, the math was the theology.
The geometry was the proof, yes. And by abbreviating the science, by flattening the spiral into a loop, we broke that link. We lost that integration. Modern tech gives us power over time, but it can't offer that integrated view. We've put science over here and meaning way over there.
It's amazing that a simple shift in geometry, from a flat ellipse to a dynamic spiral, could carry that much cultural weight.
Well, it changes your place in the universe. On an ellipse, you're just going in circles. It implies stagnation. Groundhog Day on a planetary scale.
A treadmill. You run and run, but you never leave the room.
A treadmill. But on a spiral, you're going somewhere. Every year is a new step on a journey. It implies evolution. It implies a direction. The universe is a process, not just a machine.
And that's what the ancients were tracking, the journey.
The passo a passo, the step by step. They saw themselves as travelers on a cosmic vessel.
This all makes me wonder what else we've put in that basic box that's actually, full of magic.
That is the danger of the basic trap. When you label something as resolved, you stop looking. And when you stop looking, you miss the spiral. You miss the web.
So these texts, they're not asking us to throw away our telescopes.
No, absolutely not. They're asking for a synthesis. They believe if we rethink concepts like the ellipse, we might correct some huge errors of interpretation. It's a call to merge the precision of modern time with the profound geometry of ancestral space.
Imagine if we could actually do that. Have that conversation between the Maya sage and the NASA scientist, but with a translator who understood both.
That would be a complete astronomy. That would be seeing the sky with both eyes open.
It really puts a new spin on just looking up at the night sky. It's not just a ceiling anymore. It's a path. And it makes me feel a little bit smaller, but in a good way.
It's a huge perspective shift.
We've covered a lot of ground today. The communication breakdown, time versus space, the ellipse versus a spiral, and this idea of the Earth web.
It's a lot to process. It challenges images we've had since we were kids, and it's okay if that feels a little weird.
Definitely. And I want to leave you, our listener, with a thought to chew on. We talked about how the ancients saw this order, proportion, and harmony as proof of the sacred. And we talked about how we often see our orbit as a flat, repetitive loop.
The daily grind.
Right. So here's the question. If we stopped looking at the Earth's movement as a repetitive loop of grind and started seeing it as this complex, harmonious spiral soaring through space, how would that change our relationship with the universe? Or even just with our own lives?
It's the difference between walking on a treadmill and climbing a mountain. One keeps you in place, the other elevates you. If we saw our journey as a spiral, maybe we'd feel less like cogs in a machine and more like travelers on a very specific, sacred path.
A path with order, proportion, and harmony. I like that. It makes the sky feel a lot less empty.
And a lot more inviting.
Thank you for guiding us through this void.
My pleasure.
And thank you for listening and joining us on this deep dive. Keep looking up and maybe try to see the spiral. Catch you next time.